Hi, this is Will Brown, and this is an update on my ImagineIT project, as well as some other things that I have going on, which I most certainly wouldn't be exploring if it weren't for the program through Michigan State. So, without further ado, my ImagineIT project. As many of you know, my ImagineIT project is about bringing beauty back to math, and maybe talking about students with some math that wouldn't traditionally sit in in the classrooms that I've taught in the past. I teach Algebra 2, and it's been a very traditional Algebra 2 in the past. I spent most of first quarter this year talking about linear equations, and although linear equations in themselves have some beauty and it's interesting, it doesn't bring in all of the patterns that are beautiful in math. And so I started out the year asking students to create a poster because I wanted to get like a baseline information about what their interpretation of what is math. And so I gave them 30 minutes in groups of 4 to 5 to create a poster answering just that, answering the question, what is math? And many of them, all of the posters, alluded to what I refer to as the language of math. They talked about numbers. The posters included equations. They included different operations, different representations of numbers, fractions, decimals, things like that. And then many of the posters included the words everywhere, but there were no details about where math could be found beyond numbers and equations. And so I found it interesting that students kind of had an idea that math is everywhere, but they didn't really know how to find it. And so after they created that poster, the next thing I did was I gave them an article entitled Bamboo Math. And so the article discussed growth patterns of bamboo, flowering patterns of bamboo. And apparently bamboo flowers in cycles, and those cycles are very specific products of prime numbers. For example, some bamboo cycles in patterns every 5 years, and so some cycle in patterns every 5 years, every 15 years, every 60 years, and every 120 years. But within the breakdown of those years, 5 is one of the prime numbers that's involved. And so, even if the bamboo patterns, or I should say flowers, every 120 years, which some does, right? Some bamboo does flower every 120 years. That 120th year is also the 5th year of the bamboo that flowers every 5 years. And so, I gave students this article to read. I asked them to summarize it and to discuss the math that was involved within it, and then I went around group to group and had like a little book chat, I guess I'll say, with each group in my class, just discussing what they had read and what they thought was interesting. And this was definitely related to biology because they talked about the reason that bamboo does this is because of predators, right? If the bamboo that flowers every 5 years and the bamboo that flowers every 120 years both flower but in different years, then maybe there's not enough seeds to reproduce new bamboo plants that are left after the predators eat the seeds. So that was my first project. And the second thing I did was I talked about the Fibonacci sequence and talked about the Fibonacci spiral and the golden ratio with students. And I had them go around the school building and take pictures and upload those pictures. I used LensMob, so thank you for that. And I had them upload those pictures to the LensMob site just of Fibonacci numbers that they found in nature. Right, so it had to be something in nature around the school, and I had the unique situation where my school is placed within an urban farm, and so students went to the greenhouse and were able to take some pictures. They found some desert succulents which grow in patterns of Fibonacci numbers and in the Fibonacci spiral. So I had students do that, and my project kind of transformed a little bit after that, because I was talking about the beauty in math, but I guess it kind of changed more into just finding patterns in the world around them. And so I was talking with a history teacher one day, and he said that they were talking about World War I. And so I had the students graph some data dealing with World War I and war profiteering. We were talking about companies that were war profiteers and how their profits increased dramatically from we compared their profits from 1910 versus their profits from 1914, and just talked about the dramatic increase. We talked about the percentage increase. I had them graph as if it were a linear equation, because a lot of them did form linear patterns, and so I had a little discussion about regression from that. And then I also had a discussion about regression for Breast Cancer Awareness Month. And so I had students read an article talking about different statistics with breast cancer and the risk of getting breast cancer. And so I had them do that activity as well. And then after that, I did something else I've never done before. I took students on a field trip, and in talking about patterns, I went out with my junior team, and when I was discussing this pattern theme that I have going on for the year, they said, hey, maybe we should pick up each quarter, we should pick up a different theme. And so in first quarter, we talked about World War II. And so this is another thing that's definitely not necessarily the beauty of math, but kind of the intimidating thing in math, I guess I'll say. We took students to Redgate Woods, which is the site where the Manhattan Project, one of the sites where the Manhattan Project really got off the ground. The world's first nuclear reactor was originally built inside a squash court at the University of Chicago, and while that was built and while that was the operation of that was beginning, out in Redgate Woods in Palos Heights, Illinois, there was a big military installation that was being built so that nuclear research could be done. And it's out in the middle of this big forest preserve, huge forest preserve land. And so once the installation was built there, the nuclear reactor was actually moved from the University of Chicago, I think this was in 1942, maybe 43, was moved from the University of Chicago into the woods in this place. And so we took the students out to, it's about 20-25 minutes away from the school, so we actually took the students out to the place where the nuclear material was enriched for the 2 bombs that were dropped in Japan. It's one of the greatest engineering feats in physics that occurred, and we harnessed that power and that engineering feat and used it for destructive purposes and constructive purposes, some could argue as well. But at the time it was used for the purpose of the bomb. And so we took students out there, and so in that we were asking them to answer the question whether or not they would they would have dropped the bomb if they chose to. And so, being the numbers guy, my portion of that was to impress upon students, two things: the magnitude of what occurred, and to impress upon them to be leery of data, right? Because we have to worry about representation, about who is who is presenting data, and so when I was discussing with them the number of deaths that occurred, I found numbers that were as low as 15,000 and numbers that were as high as 200,000. And so, it's very difficult to say the number of people that were actually killed in Japan as a result of the bombings, because everybody has an agenda to push when it comes to war statistics. And so, obviously, people from Japan and people who supported Japan would be, trying to make those numbers look maybe larger than they were, or maybe even just presenting accurate numbers. And people from the U.S. Were trying to minimize those numbers and not let people know the number of civilians that were actually killed, because the bombs were dropped on civilian cities. And so I did that in two ways. First thing I did was I talked about bomb blast ratios. If the same two bombs we dropped in Japan were dropped on two U.S. cities, so if they were dropped downtown Chicago and in New York City as well. And so there's a website that I found called NukeMap 3D, which will actually show you the blast ratios, or the blast radii, I should say, for specific nuclear bombs that you pick. And so it gave students some hard data, I guess I should say, about the death that would occur if those bombs were dropped in the U.S. today. And so, that I think that information could help them in making the decision of whether they would have dropped the bomb or not. When we actually went out and took the students to the woods, I wanted to impress upon them the magnitude of the construction that occurred out there, because we're out in the middle of a forest preserve, and this installation was built in the early 40s, and so, and it was shut down in the 50s and moved a little bit northwest to what is now, I believe now, Argonne National Lab. But they dug a trench out in the woods and buried a lot of the nuclear material. They just dug a 40 or 50 foot hole and threw the nuclear material in it, put a concrete box on top of it, and put 2 feet of dirt on top of that, and the nuclear material is still buried out in the woods out in Palos. And so we did a volume activity where students took measurements and calculated the amount of volume, the amount of earth, I should say, the volume of the earth and the weight of the earth that had to be moved just to be able to bury that material out in the woods. So that was another thing that I won't say is the beauty of math, but numbers can be used to kind of impress the magnitude of situations and the magnitude of something that occurred. So that's what I used that project for. And then the most recent thing that I've done with my ImagineIT project is I played a tool song for students, Tools Ladderless. And there's all kinds of Fibonacci sequence, Fibonacci numbers involved in the song. The lyrics begin at 1 minute 37 seconds, which is 1.617 minutes, which is almost a golden ratio. The number of symbols per line are 1, 2, 3, 5, 8, and 13. So all golden ratios. The song talks about a spiral.